this is Dr. Rainey again. So today we are going to do lab 11, which is gas concepts. So in this experiment we're going to use two types of gas laws. One is called as combined gas law. If you see, this combined gas law is P1 V1 over T1 is equal to P2 V2 over T2. What is P1? It's partial pressure, initial partial pressure. That's V1 is initial volume, T1 initial temperature, P2 final pressure, final volume, final temperature. So we are going to use this law, combined gas law, in doing this our gas concept experiment. We are going to also use one more law, which is called as Dalton's law of partial pressure. So what is Dalton's law of partial pressure says? The total pressure of a mixture is equal to sum of the partial pressure of individual gases. So here we're going to use, in a closed system, you're going to have a partial pressure of hydrogen gas and partial pressure of water. So we got the total pressure will be pressure of water plus partial pressure of hydrogen. So in the experiment, I'm going to give you the total pressure, which is the atmospheric pressure, and I'm going to give you the partial pressure of water at that temperature. And how do you calculate the partial pressure of hydrogen? You just subtract total pressure minus pressure of water. You'll get the partial pressure of hydrogen. And then this partial pressure you're going to incorporate here. That's what is your P1. This is what your P1 is going to be. And then we're going to do the V1. Where does the V1 comes from? V1 comes from the experiment. And the initial temperature also comes from the experiment, what temperature we are going to do. All this is given in the tabular form in your data. Now, what is P2? This will be called, this part is as a standard at STP conditions. What is standard temperature and pressure? Standard temperature is always T is equal to 273 Kelvin. So your T2 is 273 Kelvin. Now, what is your standard pressure? Standard pressure is always in 1 atm. Standard pressure is 1 atm. So this is again a quiz question or a test question. What is STP stands for? STP stands for standard temperature and pressure. Standard temperature is 273 Kelvin, or how much is it in Celsius? It's 0 degrees Celsius. And what is the standard pressure? Is 1 atm or 760 millimeters of mercury. So you can, but we are going to use everything in atm, atmospheric pressure. So what is this reaction? What is this experiment about? So today what we're going to do is, we're going to do this reaction. This is again, what type of reaction is this? I have A plus BC. So A plus BC, I'm going to write here, A plus BC gives you AC plus B. Who is getting? So how many people are getting kicked out? One person. So it is a single displacement or a single replacement reaction. So I'm going to do this reaction. So when a metal reacts with any acid, here I'm going to use hydrochloric acid. It's a corrosive acid. And what happens? It forms a corresponding salt. In this case, it's magnesium chloride. And what gas is given out? Hydrogen gas. If you want to measure the volume of how much hydrogen gas is given out in a reaction, you have to do this reaction in a contained environment or in a contained reaction vessel. So for that we are going to use what is the instrument called as radiometer. I'm going to show you this later. So in this reaction, this is the reaction. So here if you see how I just balanced this equation. So how I took one, there's one magnesium, there's one magnesium, and there is two chlorines here. So there was no chlorine here before, but I put, because to make it 2, I put 2 here. So my chlorines are balanced. But how many hydrogens it became? 2 times 1, 2 hydrogens. How many hydrogens are here? There are 2 hydrogens. So we're going to do, so this is the balanced equation. So we're going to see. So now we're going to see. So what is the, if I ask you, what is the, how many moles is this? There is no number, means it's 1. So 1 mole of this is giving you how many moles of hydrogen? There is no number. So what is that? It's 1 mole. So 1 mole of hydrogen gas is given. So if I take hydrogen gas, so if I take 1 mole of magnesium, which is equal to how many grams? 24 grams, because magnesium is, the molecular mass of magnesium is 24. So if I take 24 grams of magnesium in this reaction and I take excess of hydrochloric acid, how much of hydrogen gas I should get? How many moles? It is 1 mole. So now you will come across one more concept, which is called as a molar volume. Molar volume. So what is molar volume? Sorry. Molar volume is like molar mass. Mass of 1 mole of any substance is called as molar mass. Likewise, molar volume is volume of 1 mole of any substance, 1 mole of any gas, of any gas is called as a molar volume. So there is a number for molar volume. So molar volume of any gas. So how much is the molar volume of any gas which occupies that STP? That STP, 1 mole of any gas, it always occupies 22, sorry, my marker is not darker enough. So 22 point, what it is? So it is 22.4 liters. This is called as a molar volume. Is molar volume is 22. So if I ask you what is the molar volume, how much is equal to 22.4 liters is the molar volume. So if I want to convert this into milliliters, how do you do that? You multiply this 22.4 times 1000. You will get in milliliters. So how much it will be? 22,400. Right? So that many ml. So if I take 24 grams of magnesium, how many milliliters of hydrogen gas I will get according to this equation? Because the mole to mole ratio is 1 to 1. So how much? It will be 22,400 ml of hydrogen gas is coming out. So today what we are going to do, I'm not going to do 24 grams of magnesium. It's a large amount. So, and I cannot contain 22,400 ml of hydrogen gas. So I'm going to take today, I'm going to take only 20 milligram. So 20 milligram. So I'm going to take 20 milligram. So how do you convert into milligrams to grams? So how many? So you divide by 1000. So when you divide this by 1000, you will get in grams, because one gram is 1000 milligrams. So you do 20 divided by 1000, that many grams you will get. So how much will be? It will be, so whatever number you get, that's the number you put here. So that's the 20 I think it will be 0.02 grams. So today we're going to do, so we're going to take this, you cancel this 0, you cancel this 0, then you cancel this and you put 2, and you cancel this and you put 0. So it will be 0.02 grams. So today we're going to start with 0.02 grams, and I'm going to see how much I will get. So let's calculate the theoretical volume. So how do you calculate the theoretical volume? So we know that at STP how much it will come. So from 24 grams, how much it's getting? 22,400. So you do that. You do it. So for 20, so I'm going to use a slightly darker marker. I'm sorry. So let's see, 24. Okay, so now let's do it. So 24 grams is giving you how much according to this recipe? 22,400 ml of hydrogen, right? Gas. So if I take 0.02 grams, how much I will get? So I showed you earlier in earlier experiments. How do you do this? You do the cross multiply the opposite numbers and you divide with the adjacent number. So if I want to put this in an equation form, it will be 0.02 times 22,400 divided by 24. So when you do this, you will get, I think you will get 18.9 ml when you round up. You will get this value, 18.9 ml. So that is the theoretical volume, because this is my x1. So according to, if I do this reaction without any loss of hydrogen gas in that, I should get how much? 18.9 ml. So we will do that experiment and see if we can. If I don't get 18.9 ml, that means there is a percentage error. So then you can calculate the percentage also. If I get 18.9 ml according to the reaction, then we will, there is no percentage. So how do you do this reaction? So I'm going to show you how do you do this reaction. So what do you do this? So you take the instrument which you're going to use, that is called an ediometer. So you're going to take a stand. So I'm sorry with the markers. So I'm going to use a different marker. Okay, I got a new good one. So let's see. So how? So there is a stand. I'm going to take a stand, and here there is an instrument which is called as ediometer. So what is an ediometer? Ediometer is nothing but it's a glass tube which is closed at one end and open at the other end. So it's a glass tube, and this has all the graduated markings you have for different volumes. So I think the one I'm going to use is 100 ml capacity. So this is the glass tube, long glass tube with the markings on it, and with the one side is closed, the other side is open. So this is the ediometer. So what we're going to do is we're going to take this and we're going to slightly, we're going to use what are the things I need here? I need a metal here. I need acid. Right? So what are we going to do? First, I'm going to fill this glass tube with 10 ml of 3 molar HCl. I'm going to slightly tilt it and I fill it with 3 molar HCl. And once I fill with 3 molar HCl, then I'm going to top up with all the remaining water. I could top up with water and mixture. And then what I'm going to do is I'm going to take a stopper. Here there is a stopper which is called as a stopper, has a one hole. So it's a single hole stopper. I'm going to put this single hole stopper here. And then I'm going to insert a copper wire with at the tip. I will put this whatever amount of magnesium I'm going to take. I'm going to take that magnesium. I'm going to tie this magnesium with copper wire, and I'm putting it at the tip here. And I pass through here, and I'll place this. And then what I'm going to do is I'm going to invert the whole thing, and I'm going to place. I inverted the whole thing by covering this opening. I will invert it, and when you invert and place this inverted ediometer into the water container, take another beaker with water and invert it, and then like it will look like this when after you invert. So there is an opening here, and just don't release the opening until it is under the water. And then you have your copper wire, and with this where at the tip there is magnesium here. So now when you tilt it, what happens? This acid is denser than water. So what happens? The acid comes down. It's denser. So when acid comes in contact with this metal, you will see the reaction happening, and you will see the bubbles coming out. And then we'll see initially you'll see only a few bubbles coming out. Then the reaction, as the reaction is progressing, you'll see a lot of bubbles coming out. And when bubbles are coming out, what is getting accumulated here? all the hydrogen gas is getting accumulated here because there is no way to escape, so it's getting accumulated here. So now what's happened to excess water? The water getting pushed out from this opening. And now until this, what happens is until the reaction is over, all the magnesium is consumed. And what is magnesium? What is happening to the magnesium? It is going into the solution in the form of salt. That's why I put it as AQ. And now, so all the magnesium reacts, and all the reaction will over. And then when the reaction stops, you just have to gently tap the surface so that there is no hydrogen gas molecule. Gas is clinging to the surface, and then you can record the height of this. Say this is the, consider this is the height of the hydrogen gas. So you can record this volume of this, and then that is your V1. That is your V1. Here, that's your V1. So, and then whatever, then you can calculate the V2 from this equation. You will get the P1, you will get from here, V1 you get from here, and T1, it's the temperature what we will going to give you. And since it's doing at STP, the standard temperature is 273, standard pressure is 1 atm. So only thing, so you have all, there are total 6 variables. You will know this, you will know this one you will know, and you already know this one and this. So which one is unknown? This is the unknown. So you're going to calculate the V2. That's the theoretical volume at STP. You're going to calculate. So all the calculation is shown in the experiment. So I'm going to show you that in a part B or part 2. Thank you for watching.